This is Applied Math, Lecture 2, Part 4. We're going to look at improper fractions and mixed numbers. Are you ready? Let's go. Okay, so improper fractions and mixed numbers. First off, let's start with some vocabulary. A fraction is called a proper fraction. If the numerator is strictly less than the denominator. Okay, this symbol means less than. Remember, the alligator eats the bigger number, so we're saying the denominator is bigger than the numerator. Okay, that's a proper fraction. An improper fraction of course means the opposite. The denominator is greater than the numerator. Okay, so the improper fraction has our denominator greater. Of course, if the denominator is equal to the numerator, then what we're looking at is really just the number 1 written in a weird way, right? So if we have 5 over 5, that's 1. Okay, so a proper fraction, for example, could be 10 over 11. This is proper. Okay, because 10 is less than 11. Or we could have, 2, I don't know, thirds. That's also proper. And you'll notice that both of these fractions are less than 1. So all proper fractions are less than 1. Okay. On the other hand, improper fractions are greater than 1. So if I had, let's say, 5 thirds, right? 1 written as thirds is 3 thirds, so 5 thirds is greater than 3 thirds, which is equal to 1. So improper fractions are greater than 1. So if you have a fraction that's greater than 1, it's an improper fraction. Okay, what can we do with all this? Well, improper fractions are good for calculation, okay? But when we want to report them, saying, hey, 5 thirds or 75 24ths or whatever, is a little confusing for people. So what we do instead is we say, what is the nearest whole number, or the next whole number lowest? Let me try that again. What is the whole number that is just below the fraction that we're looking at? Okay, and then say what is left over. So in this case, 5 thirds, that's the same as saying 3 thirds plus 2 thirds, right? So this is just saying 1 and 2 thirds. So this is called a mixed number. Okay, it's called a mixed number because it's part whole number and part fraction. And in a mixed number, a proper mixed number, okay, the fractional part will always be a proper fraction, because we're always just saying, here's the nearest whole number and then the little fractional part that's left over. Okay, now let's look at how do we convert from improper fractions to mixed numbers. Okay, let's start with a nice and simple example of 8/3. Okay, this is definitely an improper fraction. 8 is bigger than 3. So to convert this to a mixed number, what we're going to do is ask the question, hey, how many times does 3 go into 8? And then we need to look at the remainder. So the easiest way that we have of doing that is division, right? We can say, I'm going to use the long division notation, but really we could pretty much get the answer without having to write everything out long division style. But here we go. We can say, hey, 3 goes into 8 twice. All right, so 2 times 3 is 6. 8 minus 6 is 2, so I have 2, remainder 2. Well, what that means is 2, and the remainder of 2 means 2 divided by whatever I was dividing by before, so 2/3. All right, and if we check, indeed that is true, because 8/3 can be written as 6/3 plus 2/3, which is 2 and 2/3. So it does work. Okay, cool. Let's try it with some higher numbers. All right, just a moment. Okay, what about 175 over 126? So 175 1/26ths. So how do we go about solving this as a mixed number? This is definitely an improper fraction, so how do we turn it into a mixed number? Well, the first thing that we need to do is, well, one of the first things that we can do is get it into lowest terms, because we know the prime factorization of these numbers. This is 5 times 5 times 7 over 2 times 3 times 3 times 7, and so we could just factor out the 7s and get 25 over 2 times 3 is 6 times 3 is 18. So we have 25/18ths, and already our life is easier. So now I'm just asking the question, hey, 18 goes into 25 how many times? Well, it goes into it once, if I'm not mistaken, because 18 plus 18 is 36, right? So it's definitely going to go into it just once, so we could think of this as 18 over 18 plus what's left over? Well, 25 minus 18 is, let's see, 7, right? Yeah. So 7/18. So we have 18/18 plus 7/18, which is 1 and 7/18. Now, okay, that's good. Let's say that you're a little bit worried about this prime factorization. Okay, not a problem. Just we would have to start from scratch here. So 175 over 126, and I'm asking the question, hey, 126 goes into 175 how many times? Well, it's still 1, right? So 1 and what? So 1 times 126 is 126. And when I subtract, well, 5 minus 6, you can't do it, gotta borrow. 15 minus 6 is 9, 6 minus 2 is 4. There we go. So we've got 49. So what I have then is 1 with a remainder of 49. So this ends up being 1 and 49 1/26. Okay, but the problem here is that this is not in lowest terms. And so in order to get this in lowest terms, we're going to have to figure out what numbers go into both 49 and 126. Well, we're a little bit lucky here because 49 is 7 times 7. The only prime number that goes into 49 is 7, so it has to be 7. And it does in fact go into both. So this is once again, if you haven't practiced your times tables, practice your times tables, okay? That will help you. All right, so 49 is 7 times 7, so 49 divided by 7 is 7, and 126 divided by 7, well, let's just quickly sketch that out over here. I know we know the answer is 18, but let's just say we didn't know that. 7 goes into 12. How many times? Once. 1 times 7 is 7. 12 minus 7 is 5. And then bring down the 6. 7 goes into 56. Exactly 8 times. 8 times 7 is exactly 56. So that gives me a remainder of 0, and which is good because 7 does in fact go into 126. So my result there is 18, 1 and 7/18. That did take a little bit more work than with the prime factoring. Okay, both are valid and you'll get full marks on a test if you do either of these two ways. Just the prime factoring I think is faster. So learn your prime factors. It will help you out a lot. Okay.